Hi everyone. Today I am explaining about the problem on a implicity function. Here the problem is show that the condition by using the implicity function definition. Okay, here the problem is if a, b, c are the angles of triangle such that sine square a plus sine square b plus sine square c equals to constant, then show that dA by dB it is equals to tan b minus tan c by tan c minus tan a. dA by dB means differentiating a with respect to b. Here solution. First write it the condition. What is the condition is given? A, B, C are the angles of triangle. Okay, here these are the angles of triangle. Then sum of the angles of triangle is pi. So A plus B plus C equals to pi. By using this, write it C. How to write it C? Pi minus A plus B. And also given the condition. What is that condition? Sine square A plus sine square B plus sine square C equals to constant. Okay, here sine square A plus sine square B plus sine square, in place of C write it pi minus A plus B. Pi minus A plus B minus constant is equals to 0. Sine square A plus sine square B plus sine pi minus theta, that is in the second quadrant. In the second quadrant sine is positive. So here it is sine square A plus B minus constant equals to 0. Okay, here it is a in the form of function in variables a and b. So let us consider here it is equal to f of a comma b, that is equal to sine square a plus sine square b plus sine square a plus b minus constant. Here the function is differentiating with respect to a partially, then the remaining variables are treating as constant. So here sine square a differentiation is 2 sine a cos a plus sine square b differentiation 2 sine square b. Here b is treating as constant, so differentiation of sine square b is 0, plus here sine square a plus b, here differentiating with respect to a, so that is 2 sine a plus b. Again differentiation of sine cos a plus b, here a differentiation is 1 plus b differentiation is 0. So here it is equal to 2 sine a cos a, that is sine 2a, 2 sine a plus b cos a plus b, that is sine 2 into a plus b. Similarly, f is differentiating with respect to b, that is dou f by dou b. It is treated as fb. Here differentiating with respect to b, a is treating as constant. So here differentiation of sine square a is 0, sine square b differentiation 2 sine b cos b plus sine square a plus b differentiation 2 sine a plus b, again sine differentiation cos a plus b, constant differentiation is 0. 2 sine b cos b formula sine 2b, 2 sine a plus b cos a plus b formula sine 2 into a plus b. Okay, next write it the implicity function of the first derivative dA by dB, that is equal to minus fb by fa. Here it is the formula, that is equal to minus fb. What is fb? Sine 2b plus sine 2 into a plus b by sine 2a. What is fa? Sine 2a plus sine 2 into a plus b. Write it here, sine 2b plus sine 2 into a plus b by sine 2a plus sine 2 into a plus b. Here a plus b, in place of a plus b, how to write that? Pi minus c. So write it here, sine 2b plus sine 2 into pi minus c by sine 2a plus sine 2 into pi minus c. Here dA by dB equals to minus sine 2b plus sine 2 into pi minus c, that is 2 pi minus 2c by sine 2a plus sine 2 pi minus 2c. Here minus sine 2b, sine 2 pi minus 2c, that is in the third quadrant. In the third quadrant sine is 2 pi minus theta, that is in the fourth quadrant. In the fourth quadrant sine is negative, so minus sine 2c by sine 2a minus sine 2c, 2 pi minus 2c, sine 2 pi minus 2c equals to sine 2c. Here it is in the form of sine c minus sine d. What is the sine c minus sine d formula? Minus of 2 cos c plus d by 2, that is 2b plus 2c by 2 sine c minus d by 2, that is 2b minus 2c by 2. Similarly in the denominator also 2 cos c plus d by 2, 2a plus 2c by 2 sine 2a minus 2c by 2. Here minus cos 2 is the common term, then b plus c by 2. Here sin 2 is common term, then b minus c by 2. Here in the denominator also cos 2 into a plus c by 2, sin 2 into a minus c by 2. Here 2 all 2's are cancelled. Then b plus c, how to write a plus b plus c equal to pi, then b plus c equals to pi minus a, then a plus c, how to write that, pi minus b. So here to applying that, b cos b plus c, that means cos pi minus a, sin b minus c, sin a minus b formula. What is the sin a minus b? Sin a cos b minus cos a sin b. Here sin a b minus c means sin b cos c minus sin c cos b by, here cos a plus c, that means cos pi minus b, sin a minus c, sin a cos b minus cos a sin b. Here cos pi minus theta, that is in the second quadrant cos is negative, so minus cos a into sin b cos c minus sin c cos b by, here minus cos b, cos pi minus b cos b minus cos b, sin a cos c minus sin c cos a. Here minus is cancelled, minus here in this multiplying and dividing with the cos ab cos a cos b cos c. Here these two are getting the cancel, then we'll get the same term. So here cos a multiplying this cos a sin b cos c minus cos a sin c cos b by cos a cos b cos c by cos b sin a cos c minus cos b sin c cos a by cos a cos b cos c. Then write it separately, minus cos a sin b cos c by cos a cos b cos c minus cos a sin b cos b by cos a cos b cos c by cos a sin a cos c by cos a cos b cos c minus cos b sin c cos a by cos a cos b cos c. So here write it separately. Here cos a cos c's are cancelled, cos a cos b's are cancelled. Here cos b cos c's are cancelled, cos b cos a's are cancelled. Remaining terms is sin b by cos b tan b, sin c by cos c tan c, sin a by cos a tan a minus cos sin c by cos c tan c. So here this minus, write it here denominator, because of our condition is tan c minus tan a. So here tan b minus tan c by minus tan c minus tan a. Hence proved the condition. Our condition is to show that a by d equal to tan b minus tan c by tan c minus tan a.